Geometry. So now we're going to be using the geometry patterns and properties that we learned to find all the missing angles in these questions. So the first one, we see that we have a triangle and the area angles all add up to 180. Remember that this one is a right angle, so that's 90. There are two ways that we've been answering these. One of them is to say we have 180 and we're going to subtract the 90 and subtract the 38 to figure out that that answer is 52. Or some of you like to add these two up, 90 plus 38 and get 128, and then subtract 180 minus 128 to get the 52. Either is correct. I would accept either of those answers to get that x is 52. Let's go look at the one below here. This one is an isosceles triangle. We know it's an isosceles triangle by seeing that this side is equal to that side. That's what this says. Because they are equal, the two opposite angles are also equal. So this is going to equal this. So we can stop and think. We know that we have 180 in total. And if we take away the 40 that we know, that's going to leave us with 140 left over. But that 140 has to be divided evenly between these two equal angles. And so I'm going to do 140 divided by 2 to get that each of them is 70. So this one is 70 and this one is 70. And if we stop and think about it, 70 plus 70 is 140, plus 40 is 180, so it works. So that's using the two properties of triangles about knowing that they all add up to 180, the interior angles. Next over here we have two angles. We learned a new way to describe these. They were called supplementary, or also known as linear pairs, because they lie on the same line. So a linear pair. A linear pair adds up to 180. A straight angle is 180. So this much is 107. So if we have 180 in total and we know we got 107 right there, whatever's left over must be the answer. And so this is 73, so that right there is 73 degrees. So remember the key on that, they are linear pairs, and this whole angle here is 180. We already got 107. That means the rest must be 73. In this one we have two parallel lines, and then we can use all of our patterns to figure out any other side. I'm going to start by looking at C as a linear pair again. You see it's on this straight line right there? And so this side must be 180 minus 57. So the C angle is going to be 123. So this is 123. Now, you might also see not just that linear pair, but you might see this linear pair. Either way, you would still subtract and get that this angle is also 123. But I know some of you are noticing one of the properties, and that is the X pattern, or the opposite angles. So you see that these opposite angles here, this one and this one, have to be the same. And that means the D is also 123. And now we're going to go off and try and find E. And in E, I see an F pattern. So I'm going to draw my F. It's upside down. But these are called corresponding angles. And you see that the same angles in the same spot must be equal. So if this is 57, then that's 57 as well. And I figured out all my angles. Another way to see that it's 57 is to do the C pattern. You see the C pattern goes like this, And in the C pattern says that these two must add up to 180. Let's check. 123 plus 57, that's 70, 80, 180, so it's right. The only other pattern that's not being asked in this question is the Z pattern. And so we could also do the Z pattern and see that this is equal to this. So this is 57 as well, even though it wasn't asked. So you guys were really good at coming up with all those patterns and seeing these different angles. So again, I'm going to send you up to the whiteboards to try these 4 questions. Make sure everyone gets a chance to try them. You can pause the video and we'll come right back. All right, so hopefully you've had a chance to check with your neighbors and your elbow partners about these answers. And so we see we've got answers of 27 and 143. So B is 27, C is 27, and A is 143. This one, they add up to 180, so just subtract, we get 53. Here's another upside down isosceles triangle, so you know those are 73, subtract them from 180, and then your opposite patterns get you all of those sides as well. Next, we've got our circle properties. 4 of them: the perpendicular chord, angles in a semicircle, inscribed angles, and angles subtended by the same arc. So let's remind ourselves of how they are used by answering these 4 questions. So you see here, we have 2 angles subtended by the same spot. So here are these 2 points. We have the center angle, and then we have the one out here. And the property says that the center angle is twice as large as the other angle. So if this is 56, then this one must be twice as big. So this is going to be 2 times 56 for 112. So that angle is 112. Over on this one, again, we have 2 points and 2 angles created from them, except both of them go to the edge. In this one, one of them went to the circle, but both of these, or sorry, to the center, but both of these go to the edge. So when they both go to the same edge, we have this property here. Going to the same edge means that they're going to be exactly the same. So that and that are equal. In here then, since they go to the same edge, this is also equal to 40. That's 40, and this is 40. Just using the property. Next, we have a diameter and 2 points coming from the diameter. This one's here. Let's find that one first. Well, if we go back to our properties, that's the angles in a semicircle. So we have a diameter and coming to a point, and that's 90 degrees. So in ours, in here, we have this is 90 degrees. So we know right away that that's 90 degrees. Similarly, this one over here also goes to the edge. So that is 90 degrees as well. Which means in this top triangle, we have 2 of the angles, and we just have to find the third. It's 180 minus 90 minus 27 gets us 63. And so this is 63. And in our last one, we're going to use the perpendicular chord, which says if it comes to any chord, it's going to bisect it. It's going to cut it into 2 equal parts. This is going to equal this, and it's going to happen at a 90-degree angle. So here we see this is going to equal this, and that's going to be a 90-degree angle. So, since it's a 90-degree angle, I've got inside here, I've got 180 minus 48 minus 90. Just going to have to check that one for me. 180 minus 48 minus 90 equals 42. So there's 42. And then I apologize, I'm running out of time, so I'm going to have to pause the video here. But you should see the Pythagorean Theorem right here. And if the whole thing is 6, that means this side is 3 and BC is 5. So you have to use x squared equals 5 squared. Oh, sorry. The 5 squared is the hypotenuse. So 5 squared equals x squared plus 3 squared. And that'll get you that x equals 4. So I'm just going to stop my recording because the class is coming in. But hopefully we can have that. And you'll be all done. Great job. Thanks very much.